Cool, should be live. Morning everyone, hope everyone's well. So the last live lesson pretty much for the summer. It's not going to be the last lesson because I'm going to keep uploading them as we go through to make sure they keep ticking over, because basically what I want to do is create a bank of all of the different topics for the GCSE as we go through. If I get people emailing me saying actually need some help with particular areas, I don't mind jumping online as well and doing the odd sort of live session throughout the holidays if we need to. But we'll arrange that as and when we need it. As usual, I'm going to do a Google Meet straight after this, so I'll put all the details up once we've finished. Now, we've been looking at, let me just bring up, actually move that out of the way. That's better. We've been looking at quantitative chemistry. So we've looked at this idea of moles, we've looked at balancing equations, and we've looked at a brief formula. And then we've looked at lots of different ways of applying those concepts. And some of you started getting to the idea last time round of how to apply them, but we haven't really put in any other additional content. We literally just looked, and let's just write those down again. We looked at balancing equations, and I've posted up some resources on how to do that. So we looked at balancing equations, we looked at this idea of moles, it being just a quantity of something, and then we looked at this formula where we've got moles equals mass divided by molecular mass or atomic mass if you're only looking at atoms. And then we looked at ways of working out how we can actually apply this. And we said that as chemists, one of the things we want to do is work out, yeah, brilliant, cheers, that's Tanishka, I'll talk to you about that later on. We sometimes want to work out how much of a particular, the quantity of a particular reagent that we need to use to make a certain quantity of product. And we said actually it's very similar to baking a cake. If we want to double or triple the size of the cake, we double or triple the ingredients we need to use. And chemistry is exactly the same. I mean, I was talking to some students yesterday, and cooking is chemistry. We are literally combining ingredients together. We are generally heating it up in order to create a chemical reaction which changes what we start with. Chemistry in a lab is no different from that. We're just not using edible chemicals in most cases. We're starting off with different chemicals. We know how much we need. We know how much we want to produce. And that's literally all we were doing using those three concepts from the past 3 or 4 lessons. I'm going to put up one of the equations now just as a quick recap. If you're looking at this and going, I can't remember any of that, there it is, then go back and watch one of the previous videos or jump on the Meet afterwards, because I don't mind going through some of it again. So let's have a look at, let's do the last one I think I posted yesterday. Wednesday. Let's put it down there. So we're just going to do one of these, and then I want to move on and have a look at something different, because we've spent quite a bit of time looking at this. So if there is still some issues or some areas that you need to go over, absolutely fine. That's perfectly normal. But jump onto the Google Meet afterwards so we can go through it then. So we've been using the scaffold. Let me bring that on as well. And we said we generally just scaffold in exactly the same way each time. I've been using a table, but realistically, using the table is just a way of using this formula at the top here. Okay? Did you get the sound, Raoul? Because I shouldn't have any sound on the computer at the moment, so it shouldn't be being picked up. So, let's just go through. I think I've got the sound turned off, but let me know if you get it, because that'd be quite an unusual one. We know it's balanced, because they've got that there, so let's just write this in. Let me just change colour. Ooh. 2Na plus 3N2. Brilliant. That's really unusual. Shouldn't get that sound at all. Anyway, let's carry on. I'm going to copy the mass across. We can talk about that now. Of 130 grams, and I'm just going to copy that in under the sodium azide, which it says is this Na3. So even if we didn't know, and I wouldn't expect you to know what sodium azide is, it tells us in the question. So it's one of those things of RTFQ, read the flipping question. A lot of the information is going to be in there. So that's 130 grams. And it wants to work out what the mass of nitrogen, which is this one, that is produced. Say hi to Rosie. Hopefully she's doing this calculation as well. I think it's brilliant that we've got a 10-year-old doing quantitative chemistry. So I'm going to work out the molecular mass now. So as we've done before, sodium is 23, and I've got one of those. I've got 3 nitrogen. Which is 42, I think, which should give me 65. So the mass of this one is 65. The mass of of nitrogen molecule is 28. So as we work our way through, as I've done before, I'm just going to change colour again to make it easy. I want to work my way down the table, so I'm going to divide. So I bring up my calculator. And I'll bring my calculator over, although I think it's going to put it straight in the middle. There it is. Let's see if I can move that over to here. Brilliant. That should get it out of the way for you. Right, so I'm going to use my calculator now, which is 130 divided by 65. Nice and easy. I should have done that in my head. Not enough caffeine and been up way too early. Now, this is the thing where people would often lose marks for the final bit. To start with, we're probably going to have at least 2 marks for this question just on what we've done. Now, if you notice, my ratio is 2 to 3. That means for 2 molecules here, I'm going to have 3 molecules on this side. They've made the maths nice and easy already for this, but they won't always do that. I'm now going to multiply back up the table again. So I'm going to bring my calculator back up for me. I know for you, you can already see it. 3 multiplied by 28 is 84. So my final answer should be 84 grams. So the working out for that shouldn't be anything different from what we've actually done before. It's just a case of going through nice and logically and just go through step by step every single time. And once you've done enough of these, you won't even have to think about what you're doing. You'll just work your way through. But remember, this table is just a way, and again, just a way of using this formula here, but we're only actually using 3 ideas so far. We haven't introduced anything new. It's just a way of applying it. Now, what I want to move on to have a look at a couple of things. The first thing, because I know you all love percentages, judging by the groaning we got last week when I mentioned this one, we're going to look at percentage masses. Now, what you sometimes get in a question would be what percentage of a molecule is a particular element. And let's just give you an example of this. We'll take sulfuric acid. And we may be asked what the percentage... Sorry, let's just take that off. What percentage of H2SO4 is oxygen? Okay. So what we do, as you've done before, we're going to work out the molecular mass, which is going to equal 98. You've done this one before, you did it in a previous lesson, so I'm not going to go through and show you how to do it. The next thing we need to do, actually no, I will go through and do the working out, and you'll see why in a moment. So, hydrogen is 1, and I've got 2 of them, equals 2. I've got 1 sulfur, and I've got 4 oxygen. Add them together and get 98. To work out the percentage, we take the amount of oxygen and we divide it by the amount of the total mass. So it'd be 64 divided by 98 multiplied by 100. And that's it. So put that into a calculator. And I get 65.6 1.3%. Okay, I'll give you another one. Like I said, this is actually quite simple if you lay it out in this way. Everybody don't like percentages, just follow how we work our way through with this one. Let's take ethanol. So this is basically alcohol. C2H6O. So we're going to go through and work out the molecular mass. This is step 1. So I've got 2 carbons, which is 24. I've got 6 hydrogen. And I've got 1 oxygen. So that's 12, 16, 2, 3, 46. We then want to work out, I don't know, I mean, we could just work out the percentage of carbon. So carbon's 24. We do 24 divided by 46 multiplied by 100. 52.2%. Okay. Thing is, Raoul, when you're looking at this first bit, you did loads the other day. We've done loads of practice on this. All you're doing is taking whichever element you need, which you've already worked out, and then just dividing it to work out the fraction. That's it. Remember, the maths at in GCSE science will only ever be up to foundation level maths and GCSE maths. Okay? They won't ever go above that. So it should only be foundation GCSE math skills, which will be the maximum of where you go up to with what we're doing at the moment. A lot of people, and I did this with somebody the other day, I had somebody who was doing further maths, was finding it difficult to go through and do the science, because in their brain, science is completely different to maths. Even though maths is a universal language, it doesn't make any difference what the subject's in. Okay, so let's go down and look at another couple of these, and then we'll move on to the next bit. Let's take ammonium sulfate. So we've got ammonium sulfate, something slightly harder. The steps, though, should be identical. What I want to do is I want to work out the percentage of nitrogen in this molecule. So let's go through and have a look. I've got 2 nitrogens, because remember, everything inside the brackets multiplied by the 2 is 28. I've got 8 hydrogen. I've got 1 sulfur. And I've got 4 oxygen. Add those together. 8, 16, 18, 22. And then I've got 2, 5, 11. There's 132. If there's calculations, Lily, it would still be maths. It makes no difference. And at the end of the day, I mean, most of what we do in science is just trying to find answers to questions. And again, that's universal across subjects. But yes, if they were to bring some number analysis in of some form, or symbol analysis in any way, shape or form, it doesn't make any difference what the subject is. Okay, so we want to work out the percentage of nitrogen. So we've got 28 divided by 132 times 100. 21.2%. So try not to overcomplicate this. Again, people, because they've done percentages in maths, they automatically say it's going to be difficult, and their brain tells them. But actually, when we start laying it out this way, it shouldn't hopefully get too complicated. It's just having the same system every single time and just going through and working that out. And like I said, that particular molecule, that's probably one of the hardest ones you might get at GCSE. So if you can do that, everything else is going to be fairly straightforward. We'll do one more, and then I'm going to move on to something else. Okay, let's write a molecule out in a slightly different way. We're going to do CH3, CH2, CHO. Okay, so we've got a long molecule. Now we can actually condense this down, if we need to, into, we could actually write it in the same way as we did ethanol before. But sometimes in exams we'd get questions looking like this. I've deliberately made this molecule a little bit bigger. So let's just go through and have a look. Molecular mass to start with. Right, carbon is 12, and I want to work out how many I've got. So I've got 1, 2, 3, 4, 5, 6. Hydrogen, 3, 4, 5, 6, 7, 8, 9, 12. And I've got an oxygen in the middle. So 72, 12, 16. Add it together, 6. So that's going to be 0, 7, 8, 9, 10. We get a number that's 100. Nice and simple then. So we could take any of these. If we wanted to work out the percentage of carbon, that would just be 72 divided by 100, multiplied by 100 obviously. Okay, and that would give us our answer. Right. Sorry, Nico, just do a reboot and you'll be fine. Going to work on the next topic now. So that's percentage masses. And let's just give that a quick label if I haven't already. I can't remember if I did that. Yeah, there we go, percentage masses. So that's that. What I would suggest you do at home is after this, go back through your notes and write an instruction guide of a step-by-step and a few bullet points as to how you work it out and what you've done for each of those sections. Again, if you need to, skip through the video, find where I've done one of the problems, have a go at doing it, and then just write a couple of steps so that somewhere written down, if you ever come across this again, you can go back through your notes and go, that's what percentage mass was, and this is how I work it out, and go through that. Right, empirical formula. Don't know why I'm doing it in red, but never mind. Some people get really, really hung up on this, on different colours. Don't like things being done in red. Now, empirical formula is trying to work out if we had the masses, and I'm just going to put in, let me just find this question I found a minute ago. It's trying to work out what the ratio of atoms is if we know their masses. Now, you will have done this before in class when we were looking at generally magnesium oxide, because it's one of the practicals we do in class. Because what we do is we start off with a known amount of magnesium, we burn it in air, so basically it reacts with oxygen, and then we work out the mass afterwards, and the mass goes up. And the mass goes up by the amount of oxygen that has bonded with the magnesium. Now, if we know the masses of those, we can actually work out the ratio. So I've got in here somewhere, I'm just trying to find the question. Let's try this one. Right. This was a question from a few years ago on a paper. I can't remember which year it is. I have to have a look. Just make it a little bit bigger for you. Probably by making it bigger, it goes slightly blurred, so I won't go too big. Right. So this was a question from a few years ago, and it really confuses quite a few students. So let's just go through and have a quick look. That's bizarre that you're still getting the noise when I'm not at this end, but never mind. It makes me chuckle. Right, so the first thing we've got is we've got some percentages, and we need to work out what the empirical formula is. And as I said before, the empirical formula is just the ratio of the atoms. So I want to know how many sodium atoms react with how many boron atoms and how much oxygen atoms. Okay? That's what we're trying to work out. So, and it's going to be as a ratio. So let's go through and we'll work this out. The first thing we're going to do, all the way through, this is going to be a ratio. We're going to do this in exactly the same way that we started doing the mass calculations earlier. Okay? So I haven't changed anything from what we were doing right at the start of the lesson when I went through and dropped that table in. So I'm going to go through and put the molecular masses. Sodium I know is 23. I think the question says boron is 11 and oxygen is 16. Now, if you can imagine, they've done this in percentages. But if I had 100 grams, that would be 22.8 grams of sodium, 21.8 grams of boron, and 55.4 grams of oxygen. So I'm going to put those in here. 22.8 grams, 21.8 grams, and 55.4 grams. So all I've done is I've just put the masses in here and the molecular masses down there. As we did last time, working my way down, I'm just going to divide each of these numbers. So I haven't done anything different to what we were doing right at the start of the lesson. I'm going to bring my calculator in. So 22.8 divided by 23. The really important thing when you're doing this is don't round it to too few numbers. So we've got 0.99. I'm actually going to go to 3 on this one. 1. Let's do the next one. 21.8 divided by 11 is 1.982. And we've got 55.4 divided by 16. 3.462. Okay, so I've literally just divided those. Come on, guys, let's keep it on track for a minute. So I've divided those down and I've worked out the number of moles. So that's just using exactly the same formula as we had before. Yeah, which is that one. Now the next thing is we need to get this into a ratio, which means one of our numbers has to come down to, we need to get into the smallest whole number we possibly can. And we do that by dividing by the smallest number. And we work out what we get. That one's obviously going to be 1. Move my calculator to a different screen. It's not a problem, Raoul. I'll just disable chat. That one's 2. Let's do the next one. And this one gives 3.5. So we can't have half a number. But however, at this point, and just so you are aware, by the way, this is a 5-mark question. Up till now, I've got 1 mark for doing this bit. I get another mark for working out the number of moles. I get another mark by dividing by the smallest number. And this will be the 4th mark here. The final mark comes from getting these to a whole number. So all I'm going to do is just double them up. So my final answer would be that, which is 5 marks. Okay? So, just go through that again. focus for a minute or I will disable the chat. The problem with disabling the chat is you then can't ask for help until afterwards. Right, so what we've done, we've started off in exactly the same way. Hang on. As we did here. Absolutely nothing different here. These questions look really hard, but the whole idea with chemistry is there's only really about 3 or 4 things that you have to actually know. Everything else you work out from the periodic table. Okay, literally everything else. So all I've done is I've used this formula, although I have brought in some information about ratios from maths. So even if we couldn't remember the ratio bit, if I can get down to work out the number of moles, we're going to get 2 marks to here. 3 marks from there, 4 marks. So this is where the marks comes in. So actually, if you're looking at this and you suddenly sit there and go, I can't get it, just work out how far you could get in the exam. If you can just divide them by their MR using this formula, you're going to end up with 2 marks minimum. If you then remember in ratios that we divide by the smallest number, straight away we're on the 3rd mark. 4th mark's from doubling them up, and the 5th mark's from the final answer. So actually, even if you don't get these 2 finished, you're going to get 3 marks. Okay? So work your way down. Now, I've got another question here just for us to have a look at, just so we can see if we can do a little bit more practice on this. Okay, so I've just literally gone online doing exactly the same as you guys could do. So I just went online and I just Googled empirical formula calculations, which is something you could do at home. So if you wanted to do practice of this, in fact, if you wanted to do practice on any calculation that we've done so far, just Google calculations. As in, so quantitative chemistry calculations, empirical formula calculations, and there'll be some web page in there where they will have made loads and loads of different calculations up, and most of them have the mark schemes with them. So you can just go through and practice the sequence over and over again and then work out whether you're right. So this particular one has a compound that is made of 57.14% carbon. It's got 6.16% hydrogen. We've got 9.52% nitrogen and 27.18% oxygen. Now, because this is not a question I've put together, I'm just going to double check to make sure that all adds up to 100. And it does. That's fine. So we're going to go through and I'm going to lay it out exactly the same way as we just did. So we've got the ratio of carbon to hydrogen to nitrogen to oxygen. I'm then going to put mass MR moles, because whenever we do any question like this or the quantitative ones or pretty much any of the chemistry questions, that's what I'm going to be writing down. So the mass of carbon is 57.14, 6.16, 9.52 and 27.18. I'm going to look at my periodic table and I'm going to put the molecular mass down. Okay, and then I want to work out the moles. So because we're going down my table, we divide. None of this should be new. So 57.14 divided by 12 is 4.762. 6.16. Oh, I needed something really silly then. 6.16. 9.52 divided by 14. 0.68. and 27.18 divided by 16. It's 1.699. Okay. Okay, so the R stands for relative, so it's relative molecular mass. I'll talk about why we've used the word relative later on, because it's to do with isotopes. But I'm not going to come in here now and confuse things too much. So as far as we're concerned, it's the molecular mass, and AR would be atomic mass. Okay. So I've worked out the number of moles, just literally using that calculation. Moles equals mass over MR. Yeah, the same formula as we've done lots of times before. What I'm then going to do is I want to turn this into a ratio. So my next step, and if you're writing a step-by-step guide to this at home, which you should be doing as we go through, if not now then afterwards, my next step to work out the ratio is to divide by the smallest number, which is 0.68. So divided by this number. Remember, if you look at your notes in a week's time and you can't remember what we did, then your notes are not fit for purpose and they're not good enough and you need to change the way you do them. And that's really important, because your notes should be a guide to the thought process you were going through while we were doing this. So that's 7.00. Yeah, so the thought process that you went through as you go in this. So if you see this again, you can work your way through the steps and repeat the problem. And if you can't do that from your notes, you need to change the way you're doing your notes. Okay. That one's 9.06. It's pretty much 9, and you'll see why in a minute. We're going to round that to a whole number. And the last one, 1.699 divided by 0.68 is 2.50. So again, we've got to this half number. I haven't chosen it deliberately on this one. It's just the way it's worked out. This is pretty much 7 to 9 to 1 to 2.5. Okay. So what I would do is I'm just going to double these up because I don't like the 2.5 there. So it's going to be 14 to 18 to 2 to 5. So if you're writing your steps down, I'm doubling up to eliminate that half number. So my ratio would be C14, H18, N2O5. Okay. So, what time have we got? 25 to. Work your way through those steps. The first part of this is exactly the same as everything you've been doing. I'm trying not to introduce too much new content at the moment because I just want you to practice and get each stage embedded. What you need to be doing though in your own time is going back through and practicing some of these equations. Remember last time I put some calculations up, a Word document online. Have a go at those. Go through and then practice some of these other ones. So I think what I'll do, I'm going to put one more question up, but I'm not going to answer it here. I'm going to answer it in the Google chat. I'd like you to have a go, and I'd like you to come online in a few minutes when I post the link with your answers to it, working through those steps. So just to go through that again. If it's in a percentage, we can ignore the percent sign and put grams. We do exactly the same scaffold as if we were working out the molecular masses from before. So we're using mass divided molecular mass is moles. We then divide by the smallest number of moles to work out my ratio. And that ratio leads to the number of atoms. So 14 carbons to 18 hydrogen to 2 nitrogen to 5 oxygen. Right, the one I would like you to have a go at home. Let's have a quick look. So, calculate the empirical formula for a compound containing, so let's have a look, 13.5% calcium, 10.8% oxygen, and 0.675%. No, ignore the percent signs. I've just realised they've actually done it in grams, so I'll just change those to grams, because otherwise you look at it again, that doesn't make 100, and you'd be exactly right. Grams. Okay, that's what I want you to work out. I will stop the stream now. I'm going to keep these going over the holidays, but remember they won't be live, but I'll be uploading some, and I can arrange some Q&A sessions if we need to over the holidays. But the next video that will be released next week will be on concentration. So we're still looking at quantities of substances, but it's going to be in liquids. I'm hoping to see all of you in Google Chat in a minute. Remember, the link's going to be in Google Classroom. Share it amongst yourselves with the people not in there, although everybody should be on Google Classroom by now. And I'll see you in a minute.